now we have seen the basics of space. We have understood what the universe is, what are the components of the universe, what are celestial bodies. We discussed about various kinds of celestial bodies. So we have covered all the basics of space. Now we move on to the second section of this particular chapter, and this is where we'll start talking about technology. What kind of technology? What is the meaning of a satellite? What is the meaning of a launch vehicle? What are PSLVs? What are GSLVs? How does ISRO work? What is the organizational structure of ISRO? How do we observe the space in general? So these are the kinds of things that we'll have a discussion on. So to start with, when we talk about space technology, just think of how many ways we make the observations in. You can simply divide all the observations into two parts. Either you are observing the space from ground, so I would call them as ground based observations, or I can do it from space. So in that case you will say that these are space based observations. How do you observe from the ground? You use a telescope, correct? This is where the use of telescopes come into the picture. So telescopes, and there are various kinds of telescopes. For example, you can talk about a normal optical telescope. You can also have radio telescopes, infrared telescopes, X-ray telescopes. There are so many kinds of telescopes, but most of these telescopes are placed on the ground and we make the observation from the ground. Yes, there are exceptions. For example, you do have things like Hubble Space Telescope, which is a space telescope as the name itself speaks. But most of the telescopes, generally when we think of a telescope, it's a ground based observation. Then comes space based observation. How do we do that? Satellites can observe the space from the space. Like for example, we launched Mangalyaan went to Mars and took the observations there. So that's why these are space based observation. If I was just observing Mars from ground using an optical telescope or a radio telescope, then in that case we'll say that these are ground based observations. Alright, so these are the ways in which we can define the various kinds of observations. So first you have ground based space observations. Now these will majorly be based on telescopes. Now widely there are two kinds of telescopes. You either have an optical telescope or a radio telescope. Now what is the meaning of an optical telescope and what do we mean by a radio telescope? So when I say optical, anything that has optical in it, it means that we are talking about light. We are talking about light, that is the visible part of the light, the white light as we say. Alright, so when we talk about white light or visible light, this is the light which is being used by optical telescope. So for example, if you have used a normal lens, it's a kind of an optical telescope. Alright, because it is using the normal visible light and making all the observations with the help of it. So it captures the visible part of the electromagnetic spectrum in the space. And these instruments uses a string of lenses and mirrors to focus into deep space, and it makes all the observations from there. And when we talk about India, some of the important optical telescopes of India are one in Devsthal, one in Hanle in Ladakh, and then you have Javdi Hills in Tamil Nadu. Now, after this you have radio telescopes. So when we talk about radio telescopes, these are little different because they are using radio waves. They use radio waves. Alright. So because they use radio waves, that's why they are called as radio telescopes. So they are not using the visible kind of the rays. They are not the rays which will be visible to us. So for example, your mobile phones use radio waves. Now these radio waves can't be seen. You don't see the waves coming out of your mobile phone. So these are radio waves, and that's why the telescopes that use radio waves for their observation, they are called as radio telescopes. So as you can see the picture, this is how radio telescopes look like. So captures the invisible radio waves of the electromagnetic spectrum. Correct? Now when it comes to radio telescopes and optical telescopes, the kind of images that they will give you are completely different. So for example, if you look at this particular picture, you have an optical telescope giving you the picture of Milky Way galaxy, and you have a radio telescope giving you the picture of Milky Way galaxy. What's the difference? Everything, I would say. This is how you would see. This is how we would see the Milky Way. Correct? This is how we would see the Milky Way, because this is what the visible part of the spectrum is. This is something that we won't observe. We would never see the Milky Way galaxy like this because it's not visible, because these are radio waves of the entire Milky Way galaxy that have been captured here. So that's why they'll look completely different as compared to the images that have been sent by the optical telescopes. Alright, so just understand what are optical telescopes and what are radio telescopes. Then after that we come to the space-based observations. Now when it comes to space-based observations, the observations are happening with the help of satellites. Alright, so that's what we are going to discuss here. We'll try to understand what satellites are. But before going to the satellites, there are a few things that are very, very important for us to understand. And that the first concept related to that aspect is the concept of orbits. That what do we mean by an orbit? Now what is the meaning of an orbit? In very simple terms, orbit is any regularly repeating path. So for example, if you are going from home to school, taking round and coming back, then in that case I can say that you are orbiting your school. So let's say if this is your school, you go from here, you take this path and you come back home. Again next day, again you take off, you follow the same path, come back home. Again the next day you go and take back the same path home. Then in that case we'll say that this is an orbit. So what do we mean by an orbit? Any regularly repeating path around an object. So in this case I can say that this school is an object and your path is basically a regularly repeating path around that object. Alright, so any regularly repeating path around an object can be called as an orbit. So that's why when we talk about the celestial bodies, we say that the moon is revolving around the earth or orbiting around the earth. Similarly, the earth is orbiting around the sun. Correct? The sun itself is revolving with the Milky Way galaxy. So in this case, we say that all these are basically regularly repeating paths. So that's why we'll say that this is an orbit. So what is an orbit? A regular repeating path that one object in space takes around another one. So this is what an orbit can be said to be. Now when it comes to orbits, generally most of the orbits are elliptical. Most of the orbits. I'm not saying all the orbits. Orbit can be of any shape. For example, when we have taken this example, you don't have a defined shape here, but it's a regularly repeating path around an object. So I'm calling it as an orbit. But in most of the cases, we see that orbits are either elliptical or circle. They are either elliptical or circular. And even when we say a circle, circle is nothing but a special case of an orbit. And even if we say that it's a circle, circle is nothing but a special case of an ellipse. So for example, you depict an ellipse like this, correct? And you depict a circle like this. What's the difference? That if I take these two lines, in an ellipse, these are called as axes. That this one will be called as a minor axis. This one will be called as a minor axis. And the bigger line will be called as a major axis. Alright? It will be called as a major axis. Now just think what happens when the major axis and the minor axis, they become equal. What will happen? You will get a shape like this, correct? And this is what? This is a circle. This minor axis and major axis, they have become equal. And when they become equal, it is called as a diameter instead of being called as a major or a minor axis. So anyway, coming back to the topic, we are saying that most of the orbits that are observed in nature, they are either elliptical or circular. Alright, we don't see other kinds of shapes for the orbits in general. Alright, now there are few terms that are very, very important when it comes to an orbit. If you look at this particular picture, you have few points. One, perigee, apogee, perihelion, and aphelion. These are four terms that you should know what they are. Of course, this is the sun, and this is the earth, this is the moon, correct? Now what happens is, when something is revolving around the earth, when something is orbiting the earth, then in that case, when they come nearest to the earth, that is the point which is called as a perigee. And when they go farthest away from the earth, in that case it is called as apogee. Similarly, in case of the sun, what we see is that when you are nearest to the sun, then in that case it is called as perihelion, and when you are farthest away from the sun, in that case it is called as aphelion. So whenever you see peri, it's always smallest distance, and whenever you see ap, then in that case it's always the biggest distance. And helion is used for the sun. So whenever you see these words, heli or let's say helio, they always refer to the sun. Alright, so this is what you can say is helio. That's why heli is being used. And when we say heliocentric, we mean that at the center you have the sun. That's why heliocentric. Alright, so these four terms, just remember these four terms for the sake of understanding of what orbits are. Now the question arises, how do objects stay in the orbit? That yes, this is a regularly repeating path, but at the same time we also have to understand that we are in space, there is no support. How does a moon, let's say for example, keep on orbiting around the earth? How does the moon keep on orbiting around the earth? The main reason is balance of forces. What we observe is that the forces that are there on the moon, between the earth and the moon, they are always balanced. That is, if there is an inward pulling force, there is an outward force as well. That for example, if we are talking about, let's say if this is the earth and if this is the moon, then in that case what's happening is that there is a strong force of gravity. There is a strong gravitational force by which the earth is pulling the moon towards it. Right? The earth is pulling the moon towards it. At the same time, if let's say there was no other force, then in that case the moon should have fallen onto the earth. But does the moon fall? The moon does not fall. So if the moon is not falling, what does it mean? There should be another force. There should be another force which is pulling the moon on the opposite side. Correct? So there should be another force which is pulling the moon on the opposite side. So whenever you have any force that is pulling something towards the center of this particular object, you call it as a centripetal force. You call it as a centripetal force. And whatever force is pulling it away is also called as centrifugal force. It is also called as centrifugal force. So in case of the Earth-Moon system or any of these kind of two body systems, the centripetal force is nothing but gravity. And the centrifugal force is what? In this case, this is the force exerted due to motion. The force that is exerted due to motion is the centrifugal force in this case. Alright. So the motion of the moon around the earth, that's something which is pulling the moon away from the earth, and the centripetal force is the force of gravity of the earth, which is pulling the moon towards the center of the earth. Alright. And these two forces have to be balanced. If these two forces are balanced, then only the moon can remain here and it will keep on revolving around the earth like this. In the absence of, let's say, the force of gravity, what happens? The moon flies off tangentially. Flies off tangentially. Alright. So what is a tangent? You know that if you have a circle like this and there is one line that just touches the circle, in that case you say that this line is nothing but a tangent. So this body will fly off tangentially if there was no centripetal force. Alright. And that's why these two forces balancing out each other is very, very important for anything, any object to remain in its orbit. This is the basic of an orbit. So the understanding of the orbits that we have today, it basically came from two people. One was Kepler and then second was the very famous Isaac Newton. So what Kepler did was that he studied the motion of the planets around the sun, and he found out that there are specific ways in which the planets are revolving around the sun. And this is where he gave his laws of planetary motion. He gave 3 laws, and these are the 3 laws that govern how the motion of planets around the sun is. Now the fun fact is that there are stories that say, or rather it's kind of a fact, a known fact, that the observations that were made by Kepler were not his own. It actually belonged to his mentor, whose name was Michael Mastley. He was the mentor. He had made a lot of observations, and studying these observations, actually Kepler came to a conclusion that there is a pattern and these patterns can be set to laws. So he gave the laws of planetary motion. So this was, you can say kind of the first understanding of the orbits that we had. And then came Isaac Newton, and Newton gave us something which is called as the universal law of gravitation. He gave the universal law of gravitation, which basically talks about each and every body in the universe. So whatever Kepler had studied and observed about planets and the sun, this is something that was applied all across any object in the universe. Any object. What Newton said is that any object in the universe attracts any other object in the universe with a force which is called as the force of gravitation. So there is a force of gravitation between me and you as well, just that it's so small because of our masses being so small that you will never observe it. So this is where we fundamentally establish the understanding of our orbit.